like. We just calculate the area under it, and then we can get the displacement. Okay? Any question? Now, the area under a curve in general is hard to solve, so I won't ask you to solve any weird area. Actually, the only area you need to know is a trapezoid. Let's say I'm looking at some velocity that grows like a straight line. So in the VT graph, it's going to be something like a constant called V naught x and a constant called ax. If you are wondering why it is called ax, I told you a hint like 20 minutes ago. But if the velocity of an object is described by this type of equation, then it is going to grow like this as a straight line. And the meaning of this V naught x will be the velocity at t equals 0. Because you can see if t equals 0, this term is 0, and the x velocity at t equals 0 should be that value. So at t equals 0, x velocity should be that value. So that's why this term is going to be the initial x velocity of the particle's motion. And this ax will be the slope of this straight line on this vxt graph. Any question with that? Good. All right, so if someone told me the velocity of an object looks like this, how do I know what the position of that object looks like? I use this equation. The displacement of that object should be the area under the vxt curve. So let's say I want to look at the particle's displacement from t equals 0 to t, then the area under this vxt curve will be the displacement I want to compute. Now, this is a right trapezoid. Do you guys know how to compute the area of a trapezoid? How about a rectangle plus a triangle? Okay, so let's do that. So for the bottom delta x, the displacement is the total area. You need to include both the triangle and the rectangle. Rectangle looks easy. The height of this rectangle is the initial velocity, and the length will be how much time has passed. So we know the first term of this area will be the height times length. So that's our first term. Any question? This corresponds to the rectangle. For the triangle, the length here is also t, and here is how much the velocity had increased from t equals 0 to t equals t. If you look at this equation, it tells you that the x velocity should go like v naught x plus axt. So if this is v naught x plus axt, and this is already v naught x, this part must be the additional axt, and that's how much the x velocity has increased during this period. So I know the height of this triangle is ax times t. Okay? And what's the area of the triangle? Is it also height times length?
Half times.
Good, that's 1/2. because triangle is just half of the rectangle. So you have 1/2 ax t times t. I can write it as t squared. And you have a equation describing the displacement of an object if the velocity looks like this. But this is displacement, we want position, we want x position. Oh, I erased that position. Alright. So what is displacement? Displacement is how much the position has changed. It's just some x minus another x. I'm going to call this x naught because if I write it as x minus x naught, then this x naught can go to the other side and becomes plus x naught. Now, if I said, yes, Stacy?
Why is it squared?
T squared?
Yeah.
Good, let's do that again. This is the area of this triangle. So the height is AT, the bottom is T. So you have 1/2 times bottom times the height.
Okay.
So you have T and T, that's T squared.
Okay.
Okay? Any other question? So here we have it. We have how the position of the object changes with time. But what is x naught exactly? So if we set t to be 0, we are looking at where the particle is at the beginning. Then t equals 0 tells me this is v times 0, this is 0. And this has some a, but t squared with 0 to be t must be 0. So all this part is 0 at t equals 0. And you see x naught is the position at t equals 0. So it is the initial position of where the particle is at, depending on which frame we're using. Okay? So you don't need to memorize this equation. Don't. You have to know how to derive it. That's how I'm going to teach you. You don't need to memorize anything. You need to know how exactly everything came from. So we claim that from this v of t, using the fact that this should be the area under the vt curve, we get that x of t should be this. Now we can double check our answer. Remember the definition of velocity, x velocity? Vx should be the x position at some later time minus the x position right now, and take the ratio with how much time has passed. Now, what exactly does x t plus delta t means? It means to replace all the t here to be t plus delta t. That's what the function means, right? If I plug in t equals t plus delta t, it means that the first term has no t, so it's just the first term. The second term has a t, but I am putting t plus delta t in that parenthesis, so I need to replace this with whatever that is. So I need to replace that with t plus delta t. That's the second term. Any question? And for the third term, there is a t squared. I need to replace t squared with that parenthesis squared. 1/2. So that is what I mean by x at t plus delta t. According to that formula, if I am looking at the x position of this type of motion, then the position of the object at some later time will be this big black dot. Okay. Now, have you guys learned distributional? You multiply each term in the parentheses by whatever is outside the parentheses. That makes sense? Have you guys learned what is this? A plus b squared, what's that? Binomial distribution, binomial expansion. Have you guys learned that? This is going to be t squared plus something. What's here?
2x2.
Good. So here I'm adding this and this, so it will be t times delta t. And the last term will be delta t squared. Any question? Binomial expansion? Right. So let me just do one more thing. I'm going to write x naught as the first term, v is as the second term, and here I have a 1/2 ax t squared as my third term. And all the rest goes down here. There's a v naught x delta t. There's a 1/2, 2, they cancel, so it is going to be ax t delta t, and 1/2 ax delta t squared. Now, if you look at this bar, you'll see that it's just x of t. So if you do x at some later time, subtract by where it is original at, you get rid of this term, and this is the rest. So what you get after subtracting them is just the second half delta t plus and then remember you have to divide the whole thing by delta t. Okay? So